This video is a walkthrough of how I built the event processing demo to summarize, to aggregate stock trading events and then submit it to watsonx to be summarized. If you just want to see what the flow does, I've got a separate video for that that's much shorter. It's only about a minute. In this video, I'm going to go step by step through how I built it in case you want to build something similar for yourself. So the starting point is an event source, a Kafka topic with the stock trading events. So for that, I went into event endpoint management because I knew I had a topic in the catalog that would be useful. This topic uses data from Alpha Vantage. Every minute, it gets a new event on the topic with a summary of trading activity over that last minute. So I'll give the source a name, including the fact that it gets events roughly once a minute, because that's useful when you're building your flow to keep that in mind. For the server address, I'm using the event gateway from Event Endpoint Management. And now I just need credentials to use, a username and password that I can use to connect to this topic. The next step is to confirm the topic that I'm going to be using. So stock prices IBM, it's a topic with stock trading events for the IBM stock, and to confirm the structure of the event, the schema, the payload shape. I don't need to change anything other than I want to use the date time that comes from the event itself, and I know that these events don't arrive late, so I can set lateness to 0. Otherwise, everything is fine as is. It's worth giving it a quick try just to check that everything's working okay. So what you can see here is the raw data coming from the Kafka topic, that historical data from the topic. The next step is to aggregate these raw events into 1-hour windows. So I add an aggregate node, give it a name to say that I'm going to be grouping these in hourly summaries, set the time window to be 1 hour based on the date time from each of the events, and then I need to choose which values I want to aggregate. So I'm summing up the volume, so that's adding up how many shares were sold in that 1-hour window. I'm getting an average of the closing price. So at the end of each minute, I get what was the price at the end of that minute. I'm going to average that out over the whole hour. I want to see the lowest price that was reached within the hour and the highest price that was reached. So that gives me like the range of prices that were seen in this stock over an hour. And I want to get an idea of the variation that was seen during the hour. And there's a few different ways of measuring that. So I'm going to try all of them. So a couple of different ways of calculating the standard deviation and a couple of different ways of calculating the variance. Now this is one of the most time-consuming bits of building out this flow, of choosing all the values and choosing the functions and choosing which value to apply it to. It does look a bit more complicated than it really is. If you understand what you're aiming the flow to calculate, it's not too bad. The last thing I wanted to see was to see what was at the very start of the hour, what was the price, and at the very end of the hour, what was the price. So I'm using first value and last value to give me that. Before I go further, I do like to rename the values. You don't have to do this. The default names are completely fine, but I like to rename it so that it's something a bit more readable, a bit more human readable, a bit more meaningful to me. If you do decide to do this, it just means you need to remember what you've called the values when you refer to them later on in your flow. As before, as I've made a change, I'll give it another quick run and check that everything's working the way I think. And what I get displayed here are those aggregate values. So for each hourly window, I can see the numerical summary of what happened in that hour. How many shares were sold, what was the average price, the lowest price that was recorded, the highest price, different ways of describing the variation of price that was seen during the hour, and so on. The next step is to turn those numerical summaries into a prompt for a large language model. So I'm using a transform node for this. So I'm going to call this generate watsonx prompt, just to remind myself what this node is doing. And for this, the SQL expression I'm using is concatenate. This lets you combine a whole series of strings into a single string. So if I give it A and B, what I get is a string AB. In the interest of time, I've prepared the expression ahead of time that I'm going to use. So this is it. It's just got all of those numerical values we were just looking at and ending with a prompt to ask for a summarization of this data in simple plain language. So I can plug this in, hit next. I now can remove all of the numerical values from the flow because I don't need them any further on in the flow. I just want the timestamps and the prompt that I'm going to submit to the large language model. As before, I'll give my flow a quick test and check that everything's working the way I expect. The generated prompts are displayed here in the table. It's a bit difficult to read them all. You can hover over it if you want to see more of the string. It can be easier to, if you pause the flow, you can download it to a CSV file, and it's much easier to read the generated prompts from the CSV file that way. But assuming you're happy with the prompts that you're generating, the next step is to submit them to the watsonx API. So I'm using an API enrichment node for this. So I called this node watsonx, and then I used an OpenAPI document with the description of the API to give all the information that event processing needs to submit event data to this API. I just need to choose the auth mechanism and plug in my username and password. So these are the credentials that are going to be used when it's accessing this REST API. The input parameters for the API, I need to specify which model I want to use. Now, there are lots of choices. I'm just going with one of the default ones, the Granite 13 billion. And what I'm submitting is that prompt string that I generated in the transform node before. The last thing to do is to just choose what output I want. So all I really want is the timestamps and the response I get from the large language model that I'm going to call summary. As I'm doing summarization, I'm summarizing the data for each hour. The last thing to do with my flow is to add the event destination, the sync topic that I want to submit these summaries to at the end of each hour. I could have chosen a topic from the Event Endpoint Management Catalog if there was one that was suitable for this kind of data, but I'm going to go directly to Kafka for this one because I've got a topic that I've prepared for this project, where I'm going to store my summaries of stock trading activity in these hourly windows. And that's the flow ready to run. You can see the output in the event processing UI here. As I was mentioning before, it can be a bit difficult to read. You can hover over it and see the text, but it's quite small. What I find easier is either to pause it and then download it to a CSV file and then review it in that file, or go directly to your Kafka topic and then view the messages on the Kafka topic there, which makes it much easier to read. So in summary, I had a Kafka topic with trading events for a tech stock. Every minute, the trading activity for that minute goes to that topic. I used event processing to create a flow so that Flink could aggregate those events into 1 hour windows and give me numerical summaries of the trading activity over that hour. I then used watsonx to summarize that and give me a plain English description of that trading activity, which I'm outputting to a new Kafka topic that every hour will get an event with a summarization of trading activity over the last hour.